This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software. This March 21st and 22nd, don't miss Tech Ignite in Burlingame, California, just minutes from the San Francisco airport. Come to Tech Ignite to get rock-solid info and forecasts on adaptive cybersecurity, emerging technologies, machine learning and deep learning, operational intelligence, and much more. Join tech superstars Steve Wozniak and Grady Booch, plus C-level leaders from Netflix, Google, IBM, Salesforce, GE Digital, and Intel to gain valuable insights and learn about real-world solutions you can start applying today. Register now for the IEEE Computer Society's premier conference, Tech Ignite, at techignite.computer.org and discover the truth behind technology.
For Software Engineering Radio, this is Robert Blumen. Today I'm joined by John Allspaw. John is the CTO of Etsy, where he was previously the SVP of Infrastructure and Operations. For over 17 years, he has worked in system operations in the biotech, government, and online media industries. He's the recipient of a master's degree in human factors and system safety at Lund University, and is the author of 2 books, Web Operations, Keeping the Data on Time, and The Art of Capacity Planning. John is a popular conference speaker on reliability, availability, and failure. John, welcome to Software Engineering Radio.
Thanks for having me.
John, we've all seen headlines about outages of very high-profile websites. Even businesses with huge economic value and lots of resources still experience unwanted downtime. I have an article, AWS suffers 5-hour outage in the US from September 2015, and one from last year, Gmail outage hits the US and Europe. I would like to talk with you today about why, in spite of our objective to be up, that systems still have downtime, how we try to avoid that, and what we can learn from it. I'd like to start with, can we define what an outage is?
Well, yeah, that's a good question. What's a failure? What's an outage? I think that these things are generally constructed. And so what one organization might say is an outage might be something different from another organization. In some cases, it's just entirely about the business. So, I mean, think about it. Some businesses are entirely driven by native apps, and their web presence is really nothing but, some sort of maybe just like introduction or brochure, really just sort of information. So if the website goes down, did you have an outage? And so I think just earlier this week, Delta had an outage. Delta Airlines had an outage. And so I think that it's context specific. I think the most important part is instead of like reaching for a common definition of outage or failure, really, I like to just refer them to as untoward events. And then that way it's a little bit more, just context specific. But in general, I'm doing some business and I can't do the business because of some of the tools that I need to run the business aren't available, or they don't work the way the people who are using them expect them.
Then it's a loss of the service that the end user wants to get from the system.
Yeah, you could probably say that. Yeah.
I'm aware that a lot of planning goes into dealing with predictable things that can go wrong in a system. What are some of the predictable things that can go wrong?
Well, that's the funny thing. So most outages, especially the ones that you hear about, are businesses that are notable, right? So the reason why they're notable is that they're probably pretty good at preventing outages. So we usually hear about the ones that aren't prevented. We don't hear about all of the outages that were prevented, which happens every day. And so, again, like if you were to look at those articles that you said about Gmail and AWS, up until the second those happened, they were pretty sure that they were preventing them. And so there's some element of surprise that is inherent in almost every outage. Because if you had predicted it and you prevented it, then it wouldn't have happened. So I guess I would say is all of the things that go into making the site run at all are all of the things that help prevent outages. It's a weird semantic thing that I think it's easy to skip over. I could tell you a little bit about, make sure you have more than one server. Make sure you have, some redundant paths from this service to that service. Or I could tell you all of those things, but those are just common behaviors, common maybe design patterns. And I don't know. That's all quite interesting, but I think it's straightforward. It can't really be construed as advice other than, carry a spare charger when you're carrying your phone, if you're going to be away from an outlet. So I feel like, sorry to flip your question around, and I recognize I'm rambling a little bit, but in software, one of the things that concerns us so much is designing to prevent failure. And I think that's absolutely a reasonable thing. It's never those things that bring about outages. Almost never, because we do the things that we think we need to do. What interests me are the things, and this was actually a part of the research question in my master's thesis, which is when our preventative designs fail us, what then? Right? What are the things that happen in an organization or technically with software when the unexpected happens? You see what I'm saying?
Yeah, that the planning to avoid failure, it is largely successful because many systems do stay up most of the time. And had the planning not been done, things would have been much worse. Why is it not so simple as we think of all the things that can go wrong, we plan for them, and we have a plan in place for each thing, and we're done? Why is it not that simple?
Well, that's a good question. I think that, one way we could think about it is that because of software and because we've gotten pretty good at software, I guess that's debatable, because we've found new avenues of enabling businesses or competitive advantages through software, that also brings new opportunities for it to surprise us, right? Because these aren't simple systems that we're building, and the opportunity for unintended consequences becomes a lot greater. And it's not because the components don't have a lot of eyeballs and critical thinking around them. All of the sort of expected things are thought of and certainly sort of prepared for. But there's always those things that aren't expected that are beyond our control. The internet is an open system. And so I would say that software reflects influences that we can't predict.
Yeah, so let me follow up on this. For any system, there are things which are exogenous to your system. There's what you define as the boundary of your system, but you're using other things, whether it's hardware that a cloud provider provides for you, somebody else's DNS. Are outages often due to these dependencies on things we don't control? And can we plan defensively around services we consume but don't own?
I mean, I think the answer is yes to that last question, and that's already the case. So again, it's about what we can imagine. It's not like, well, we can imagine this, but we can't come up with a way that's economically viable or even technically viable to guard against it. I think there are lots of pretty common ways. Again, just like you said, you can use a second DNS provider. You could use a third. You could do things like force feedback loops between CDNs or moving in distributed database systems. You can, change the number of replicas you have. And there's lots of dials and knobs, but I think that we have to accept that our imagination is what drives us to build those knobs and levers, and reaching for them when we need to is always going to be a matter of judgment. And so I guess this is a long way of saying that, yes, there's obviously a limit to preventative design. Always. And in fact, I might even argue that the reason why things work as well as they do is certainly partly because we build redundancy and hot failovers and things that can gracefully degrade, all of that. But they still have operators, right? Whether the operator is a human pressing a button or running a command, or the human is imbuing their judgment into some sort of quote unquote self-healing, right? Turning up instances on EC2 is a good example of that. We build in heuristics for auto scaling. We say, oh, well, when this criteria and this criteria is met, then launch new instances. And when, just like a thermostat in your house, really. And when it goes down, then turn them down and that sort of thing. So there's still sort of judgment in there, but I don't know, we still seem to get surprised. So the thing that interests me the most is, how do we behave? We can talk all day about how we behave in designing for those failure scenarios and exercising our imagination and anticipation skills. I think that's great. And it's actually I think it's the topic of, software engineering books and material for a couple of decades. What isn't entirely understood is what the hell we do when all of that doesn't play out as our imagination. And so I think that to address your exogenous, I think that that's inherent, at least on software that sits in an open system like the internet. You can't have users coming to your website and have a objective, deterministic idea of exactly who they are and exactly what they're going to be doing. So it can either be a depressing outlook, which is failure's going to happen, there's nothing you can do about it, and get used to it. That's a pretty dark way of thinking about it. But another way of saying is the opportunity for failure is omnipresent. And to quote Richard Cook, who has a lot to say on this topic, what should surprise us is not that our systems go down. What should surprise us is that they work at all. and they work at all because of people, not just because of software. Because we have to make active effort. Yeah. We sure did get philosophical real quickly, didn't we?
Yeah. You're making it pretty clear there is a limit to how much we can plan successfully to avoid failure. And planning twice as hard may not bring the number of failures down by twice as much. There's a point where we need to think about how we're going to respond when failures do occur.
Yes.
Should we be designing more to avoid failure or to make systems fixable and recoverable?
I think you're spot on. I think I absolutely agree with the latter. There's a great phrase Eric Hollnagel says when talking along the lines of what the resilience engineering lines of thought. What Hollnagel says is developing a constant sense of unease. I like to say constant sense of unease rather than paranoia, but that constant sense of unease brings you to think about, more like building, and this is an often used analogy, more like designing and building a Jeep versus designing and building, a Rolls Royce, Well, I don't know how it is these days, but a Jeep used to come with a set of tools. And the designers of a Jeep, it would show up with a full-size spare tire. And it would come with a set of tools. And that's probably largely because Jeep knew their drivers and knew that they were going to drive those Jeeps in not perfectly ideal conditions. So they expected that the car is going to break down in some way, or it's going to need some repair in some sort of way. And so they designed for that. And that's where this notion of designing for time to respond and time to detect versus time between failures, or optimizing time between failures.
Give us some examples of designs you use or design patterns that are aimed at time to fix.
Well, there's a couple of different examples that come to mind. If you think about schema design, database schema design, a traditional, although I wouldn't say it's traditional these days, but a traditional way of thinking about database design is through normalization. I'll store the data in one particular way, and what I'll do is I will manipulate queries around it to get the answers that I'm looking for. Well, so I think anybody who's ever built a infrastructure at scale knows that normalization is actually not at all the route to go. And there's sort of limits to that, especially when you're talking about high volumes of queries. And so denormalization, which is I'm just going to store the data in multiple different ways. Generally speaking, I'm going to store it the way I expect to query it, even if it means spreading duplicates of the data everywhere. The side effect of that is, primary key lookups in a database is really easy to think about. You don't have to draw a picture in your mind of like, oh, well, what is this join doing? And what is this really complicated query doing? You can just say, select star from blah, and where the schema design itself makes it easier to think about. The picture that you have in your mind looks simpler than something where you've got to have some weird, omnigraphal diagram in your mind when you have to troubleshoot or diagnose or debug something. So another example, and it's pretty common now, but it was shocking how long it wasn't common, is that in these systems where we're collecting telemetry, sensor data or metrics or whatever, in systems like Influx or Graphite or whatever, insert favorite time series database here, to put interesting events, draw infinite vertical line on an interesting event that may or may not have anything to do with the metric you're looking at inherently, but is used to aid diagnosis, making it easier to make sense when things aren't going. You could at least generate a hypothesis. Ooh, did we change something at this time?
Can you think of a failure or incident you were involved with where it took longer to recover because you hadn't done something that would have made your life easier?
Yes, there are a lot of examples there. This was a story from a very, very long time ago at Etsy where we were working on some pretty complicated things to detect from weak signals, detect fraud. And so where requests come from, at what cadence do they come from? Are they a bot? Is there something about the traffic that makes it look like a real human? And there's IP addresses, there's subnets, there's networks. Is it coming from a data center? Is it coming from a home IP? That sort of thing. And because we built the tools to assume a lot about how primary the IP address of a request really was, central to whether or not it was fraudulent or a fraudulent request or not. Well, to cut this story short, we banned our own office IP address because it had tripped a number of different things. And so, of course, what does that mean? It means that people from inside the office couldn't even diagnose why things weren't working. Do you see what I'm saying? So there's something we fired that gun back at us. There are a number of different things, and there's such a conundrum. There's a belief, and it's so seductive. There's a belief, especially in the wake of an incident or while you're developing new code and you're not entirely certain about its behavior. It's so easy to collect time series metrics these days. You're literally only one line of code from getting really complicated analytics around basically any event you want at almost any time resolution. Also, the upside of that is you can make a graph or something that you can use to diagnose how your systems are working so easily that we can have millions and millions of them. Many organizations do at all layers of the stack, from like Ethernet all the way up to like something like, searches on Etsy, some sort of like complicated sort of business function. And how ironic is it that it's easy to collect all those metrics, and the more metrics you have, the harder it is to navigate through them. And so what do we find in a lot of postmortem debriefings is not that, we weren't graphing something that we should have graphed. That's almost never the case. We almost always find a graph that would have helped us during the time. The data was available. It hadn't been observed, right? So next thing you know, now we got to build a search engine for our graphs. Do you see what I'm saying? So there's these unintended consequences that I think that can show up. We ended up building something and that we're kind of iterating on now. We had open sourced a project called Kale some time ago, and it was sort of the rough gist of it was, okay, I've got this graph and it was to help aid diagnosis. I've got this graph. It does this weird thing. This graph tells me something about a symptom, but I want to know more about it. So show me more graphs like this. And it was helpful. We're kind of iterating on it now. It wasn't, I think the impetus was that it would really help. It helped a little bit, but not a lot. But yeah, I think in the end, sometimes you need to build controls, knobs, levers that seem kind of crazy to build because you can't imagine a world where you would need to do it, but it almost always turns out to be useful.
Searching for a new job is stressful and scary. Then you go through the interview process only to find the salary offer or company culture doesn't match what you're looking for. Hired.com is the world's most intelligent talent matching platform for engineering. We make your job search faster and stress-free. After completing the application, top employers apply to hire you. You receive personalized interview requests and upfront salary information. Your dedicated advocate will assist you, providing career coaching to help you with potential employers. Hired.com hides your profile from current and past employers to respect your privacy. The best part? It's always free. Today's SE Radio listeners can earn a $2,000 hiring bonus by signing up at hired.com/SE Radio. Find your next chapter at hired.com/SE Radio.
You mentioned several times that these systems we build, humans are a part of the system. What is the role of human error or human behavior in causing outages?
I think I feel pretty strongly about this, which is that I actually don't believe in human error. I don't believe it as a useful concept. I certainly can call almost anything an error or a mistake, definitely in hindsight. I just don't think it's useful. It doesn't tell us anything. So therefore, if it doesn't tell us anything, I don't think it's useful to use it as a cause. And that's for a number of different reasons, mostly because the term itself draws a box around a person and not about the context that the person found themselves in. And so, where does design fit with that? I can make a website, and unfortunately, lots of websites will do this not on purpose, where it's really hard for you to find the submit button or like the piece of user interaction. If I can make it hard for you to do the right thing, then when you do the wrong thing, how much of that is you versus how much of that is my design and my intent for you to, do you see what I'm saying?
This idea that people are doing what they think is the right thing given the information they have, and they may be under a lot of stress at the moment because their employer's losing $1,000 a second.
Yep.
And you have to understand what they did, and maybe there weren't any run books and no one had told them crucial information. You have to take all of that into account. Is that where you're going?
Yes, absolutely. And I mean, that is what you've effectively described there is what's known as the local rationality principle, which is exactly that. People do what makes sense to them at the time, given their goals, their familiarity with this scenario. And sometimes it's not just time pressure. Of course, I don't know anybody who's not under time pressure, but it's also about like how confident they are with tools, how confident they are with the scenario that they're in. And when I talk with people on this particular topic, one of the things I generally do is I ask people to raise their hand if they feel really confident in using email. Of course, I get a room full of hands. And then I say, how many of you have more than a decade and would say that you're basically an expert at email? And most people raise their hand. And then I say, keep your hands up if you've ever sent an email to somebody you didn't intend to. Or if you replied all to a mailing list you didn't intend to. And almost everybody keeps their hands up. In which case I said, well, are you an expert or not? And the fact of the matter is it's too easy in email, no matter how much experience you have, to make that mistake. And so if I want to get at that, well, maybe I could get at that story. If I make it about you and you're not paying attention or the mistake that you made, well, I'm going to miss out because somebody else is going to make a similar mistake. But if I were to say, well, maybe we could look at the algorithm that does autocomplete on the to field of your email client. We could talk, we could think about that as a design effort. But yeah, you're exactly nailing it. That is generally my perspective, and fortunately it's a growing perspective that human error it's just simply not useful. I think that it's at one point in the world of safety and complex systems that we may have thought it was useful. It's just not.
You mentioned earlier Dr. Richard Cook. We're going to link to that article in the show notes. He says that most of these problems do not have a root cause, and the search for the root cause is harmful. Do you agree with Dr. Cook on that? And you're nodding. Yeah. Listeners can't see that. So why? Why is he right about that?
Well, because cause is something that we will convince ourselves of. And I've always been looking for succinct ways of getting this concept across. And there's two. One is a story, and the other is sort of a statement. And neither of them are original or mine. And I've talked with Richard about them. We don't use some different part of our brain to make mistakes than we do when we're successful, right? It's the same brain. We do the same things. And in fact, we can do one thing one day and do the exact same thing the next day. And the second time we do it, it might end up in a mistake, even though we had all of the same inputs. And so that's called the principle of equivalence, right? Which is that success and failure comes from the same place. So if you were to say that, finding the root cause of a failure would be, logically speaking, similar to saying there is a root cause of success. And I've yet to find somebody who could tell me definitively that there is a root cause of what makes them successful. That's concrete. So that's sort of one way of thinking about it. The other way, and I'm going to probably screw this up, there's a great book, came out in the 60s, and it's called Thinking by Machines. This was during the times of, maybe even earlier than the 60s. It was during the times of cybernetics. And there was a chapter that really got at this idea that cause and effect have like a domino effect. And the example they say is, if you take a metal bar and you put it into like a hot oven, right? The bar will expand, depending on the material of the bar. The metal bar will sort of expand. So then you could say, well, what's the cause of that expansion? Well, on the one hand, you could say it was because of the existence of the oven, which is not wrong. The other is that you could say, well, it's the heat in the oven, And that also wouldn't be wrong. And then you could also say it's about the temperature differential between before you put it in the oven and when it was in the oven, which is also true. And also there's also other things that make it such, that create the conditions, all of which are necessary, but only jointly sufficient to cause the bar to lengthen. Much in the same way, I could say that the cause of an outage is a person running the wrong command on the wrong server. Here's a perfect example. They shut down the wrong server. They shut down the server that was in production, not taken out of production, for example. I could do that. I can also construct a story where the runbook or the procedure that the engineer was using hasn't been kept up to date, and they followed it perfectly from their internal wiki, right? I generally ask teams of engineers, raise your hand if you can find a wiki page that has outdated information in it. In fact, if you were to follow a procedure top to bottom, exactly how it's written, you're going to have a bad day. Everyone raises their hand, right? So I can also tell a story about how the engineer wasn't trained or that they weren't paying attention. It's about where we draw a line to say what are the things that we will consider, right? And so I don't think of anything. Think of a DDoS attack, right?
Let me stop you here and just summarize. What I think you're going with this is, and I'm tying together things you've said at different points. These systems are complex. They have a lot of parts. The parts interact. In order to have a failure, we're pretty good at thinking of preventing failures when one thing happens. So generally, if we've done our jobs, a failure occurs because multiple things happened, and none of those things could be said to be the root cause, because if any one of those things by itself had happened, probably we have enough layers of protection that we're good. Now, is that a fair summary of what you've been saying?
Yes, that's exactly right.
We talked some about prevention. We talked about responding and fixing. You've also mentioned postmortem, the idea of learning from things that went wrong. How can we best learn from these experiences?
I think that there's a couple of things that might not be readily apparent. It's quite common to have a postmortem meeting or a debriefing. I think that there are multiple goals of having such a discussion or a meeting or a process. And I think one of the most successful ways of doing it is ironically not solely focusing on what was special about the event you're talking about. Let me give you a little bit of background. Let me back up. In some of the most successful, and I mean really valuable postmortem debriefings that I've been a part of, is when the facilitator or somebody in the group, usually these are sort of group discussions.
Maybe could you just briefly say what is a postmortem?
Oh, sure. The term postmortem in a software sense is generally a meeting or a discussion, or sometimes it's referring to a process. It's effectively either a debriefing or a discussion that is typically attended by a group, and the ideal scenario is that you are discussing an event and actions and decisions that surround a sort of a time-boxed event, in the hopes that through dialogue and discussion you'll learn something in order to aid prevention in the future.
Great. I interrupted you a moment ago. You were starting to talk about one of the most useful experiences you'd had in a postmortem. Let's go back to that.
I think a traditional way of thinking about a postmortem is you lay out a timeline and you zoom straight in and find That the idea would be to go and find the part that broke, whether that part is a component or a command that was run at the wrong time, or something. It's a narrowing, and we almost never learn much about that, other than, like we mentioned before. Well, you'll always, when you narrow like that, you'll find somebody who did something wrong, basically. And if you were to take a different approach, and this is the approach that I've found to be hugely beneficial at Etsy, and in other organizations as well, which is to use the event as really just an anchor for you to ask about how things normally go. And so when in a debriefing, you'll say, all right, so let's start at the beginning. Before this outage happened, Lisa, what was going on? What were you doing? And Lisa will tell you, well, I had to replace this, I had to restore this backup for this thing and whatever. And she'll go on and tell a story. And if you ask probing questions about how she normally does her work, remember, outages, like we said from the very beginning, outages are surprises. And a surprise is a contrast between the way reality unfolded and how you thought it was going to unfold, right? Which means that if you don't talk about how things normally go, you're not going to hear about, well, I ran this command and what did you expect to happen? Well, I expected that it was going to restore the database, right? So when you hear that, that's exactly what you were getting at, which is we are trying to find out what actions and decisions made sense for people, what made it make sense for them. Because what we always find are people will tell you, well, I do this and I do that. When I do this 100 times a month, and sometimes they'll say like, yeah, well, they'll want to zoom straight into that one time that they did this. No. I want you to tell me what you normally do, because that'll help us explain how you found yourself in this situation. And so that's why it's this weird thing. You're in the room because of a failure, but the greatest learning comes from when people tell you about how they normally succeed doing that stuff.
I'm the person in this meeting. I tell you I back this file up, then I expect that I see the file is there on the disk or in the folder, but it wasn't this time. What are you going to learn from that? Or what is actionable that will add some value to your organization in the future that will come from that?
So in our little hypothetical scenario, ideally, we're not going to get just this one story from you. We're going to get stories from as many perspectives as possible, right? And in that case, a network engineer says, "Oh, well, what was this, Thursday morning? Yeah, well, every Thursday morning at 10, we unmount all of the NFS mounts to do some insert, network maintenance thing here. And it takes for about 3 minutes, and generally and we just remount everything. And that's what happened. Oh, well, when do you usually do this? Oh, well, I usually do it on Wednesday night, but I was sick that day. So I just figured I'd do it the next morning. So that's where we would learn, a scenario. This hypothetical is really constructed, but you get what I'm saying.
Yes.
And then what we could say is, oh, hey, if you're going to unmount NFS, put something in message of the day, or, make it so that you can't actually put files there,
I'm going to change the subject a bit to talk about testing. We've talked a lot about planning, and that might take the form more of thinking, what if this happens, instance goes away, DNS goes down. What is the role of testing in preventing failures? And can we build a test environment? Can we test enough there to find out how it's really going to act in production?
There's a couple of questions in there. I'll take the last one because it's the easiest. No. Remember, I will have to say a really smart guy to follow on Twitter about this topic is Noah Sussman. He used to work at Etsy some years ago. And what Noah does is point out almost on a daily basis that there are always things that we don't even know to test for. And that's really the simple answer to, that's really the simple explanation about why no. So there's not a scenario where you can construct a perfect set of testing. Now, that does not mean that testing and the activity of writing testing isn't hugely valuable. I think there's something that is a source of strength, I would say, certainly a source of learning in an organization, is the act of writing tests themselves. Just because the test isn't going to capture all of the myriad things that is going to happen in production, one thing that you can do is say, and be really upfront, this is exactly what this test does. It does nothing more than this, and really flesh out the description in comments and other sorts of documentation. This is exactly what it does. So therefore, you can feel confident about it, what it doesn't do. Do you see what I'm saying? Here's where the limits of this test are. The other thing that I think is sometimes skipped over in an effort to test all of the things or provide, perfect confidence, which, like I said, is impossible, is that tests, much like all software, is really just the encoded intentions. It's a little bit like the encoded imagination of the engineer. When a developer writes a unit test, it implicitly represents what that developer does not feel confident about, absent the test, which is a really great signal. It gives you some insight. You can make some inferences about what's going on up in their mental model, which I think is really, really valuable.
Something you've written about, John, and we'll link to this in the show notes, is the concept of fault injection in production. Explain what that is and why you are an advocate.
Yeah, and there's a couple of different ways of thinking about it. Article I had written for ACM some years ago is really just a specific version or specific case of what Netflix ended up calling chaos monkey. And really what that means is constructing a test in production, purposefully in production, where you are injecting some sort of fault. And I mean an actual fault. So examples that we've done in the past are, all right, well, a month from now, we've got these new set of databases and we want to write the code so that it doesn't, go all wonky when the database isn't there. So this is what we're going to do. We're going to, on the 31st of the month, we're going to, go to the data center, or we're going to log into AWS, and we're just going to nuke, we'll either just yank the power cables from the box while it's running, or we'll just completely nuke the instance in the case of AWS.
To be clear on this, you're talking about doing this on your live production system that your business runs on, correct?
Correct. The reason why you do that, and you say, I am going to do this in the future. Now, this is a little bit different than the way Netflix goes with Chaos Monkey, and Chaos Monkey has, and the other forms of their sort of Simian army software, they might choose to do things randomly, but conceptually it's still the same, which is, we're planning on doing this. What do we need to do to make our systems not care that this happens? And what it does is exercise new kinds of imagination, and knowing that it will actually happen in real life means that you're playing without a net, and that can be really uncomfortable. But the fact is, you're either doing it while you're there and watching it, or it can happen while you're not watching and you're not prepping for it.
you're thinking we have a standby or a cluster or a failover. In theory, if the one goes away, the other one should take over.
Mm-hmm.
Let's be sure that it really works that way, because we don't want to find out to the contrary at 3 a.m. on Thursday morning.
Exactly. And I'll have to say is that once you, and as a leader in the organization, once you make it safe for people to start exercising this part of their anticipation and building this anticipation skills, and it can be really fun, to think of all the horrible things that you can do to software and hardware, and aim at making these contrived. And make no mistake, they are contrived. That doesn't mean that you're going to come up with something that's exactly going to happen like that in the future. It can be really fun to think about, how can I make it so that if my binary files of my database get totally corrupted, how do I make that? How do I make it so I don't have to care, or I don't have to freak out when that happens? And it can be fun.
You sound like really good things to know, and to know that you can deal with them. I'm going to guess here you wouldn't do these on production if you thought you could do an adequate simulation of this on a staging system or a test system that you would build offline. And
yeah.
Why do you have to do this in production?
Well, I've yet to see, and maybe this is, I've only been doing this for about 20 years, so maybe I don't have enough experience, but I have yet to meet a staging environment that is perfectly, and I mean truly and perfectly, with no doubt, a mirror of production that is seeing the diversity of traffic, the diversity of temperature, of interconnections and work as production. So, and usually what I say is, look, if you're not comfortable enough to do it in production, it just means you're not done yet.
One more testing question, then we'll wrap up. My view is, I see a lot of tools, frameworks, best practices, books, conferences, blog posts about how to test the code, which in the context we're talking about, you could call that a simple system, because the code all runs inside a runtime that's just one thing. Whereas a lot of these failures come about because of the interaction of different parts, or you have infrastructure changes, which in theory you should retest everything when you change a piece of infrastructure and make sure that all the tests it used to pass. Is it fair to say that the discipline and the domain around testing infrastructure and systems is less advanced than around testing code?
I don't know if I would be so strong. If this was 5 or 6 years ago, maybe I might say that. I think that the state of the art of configuration management, that's one example, cluster management, orchestration. I think that the state of the art there has reached a point where there is, I don't know, I'm probably not the right person to coin something like this, but there are equivalents of what you would otherwise call unit tests or functional tests, but for infrastructure, or that is to say, multiple layers of the stack. I think that the amount of manipulation, that is to say, infrastructure, so think about load balancers and internal DNS and routing and distributed databases, all of the things that surround the sort of the container ecosystem and all of the orchestrating things like Kubernetes, have turned a majority of a lot of those of the things that had always been seen as separate from the code into code, right? That this was the promise that Adam Jacob and Luke Knies and Andrew Schaefer. This is the promise that you could treat infrastructure as code, in which case you could theoretically do things that you otherwise previously wouldn't have been able to do. And I think that that's actually been going on for a number of years. And there's lots of folks who have been thinking about this problem and making a lot of progress. The one caveat that I would say there, and this maybe loops back a little bit to the very beginning, which is, and yet we will still be surprised.
That's a great place to end. To close out, John, where can people find you on the internet?
Well, I have a blog at kitchensoap.com. Don't ask me about the name. It's just 2 words that was really easy to pronounce and people would remember. And my hope is to write a lot more there in 2017 than I have in the past. The CTO gig here has been pretty busy, but that's where you can find me and listen to my ramblings.
Thank you so much. And thank you for speaking with Software Engineering Radio.
Thank you.
For Software Engineering Radio, this has been Robert Blumen.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.